Question number 21. Jim takes a tile at random. He does not replace this tile before he takes a second one. The fact that he doesn't replace it is quite crucial to this question. So calculate the probability that both the tiles he takes have the number 1 on them. First thing I'm going to do is I'm going to sketch out a really quick tree diagram which looks like this. You can see that there's the first pick options, of which there are 3, and then there are the 9 possible outcomes for the second pick. All of the probabilities have changed on the second pick, which reflects the fact that he does not put that tile back in. So for example, if he takes a 1 out first and then he takes a 3 out, there are now only 6 in the bag, and that's why the probabilities are out of 6. So the probability that both the tiles he takes have a number 1 on them is given by this branch here, 1 and then a 1. So when we say and, we multiply these two probabilities together. So I'm going to get 2 out of 42, which would simplify down to 1 over 21 as my final answer. In part B, calculate the probability that the number on the second tile he takes is greater than on the first. Well, you can tell that this is going to be a difficult question because it's now worth 3 marks. So let's have a look at it. I'm going to go back to my tree diagram and I can see all of the possible outcomes. So I'm just going to go down this list and see which ones fit the description that I'm given in the question. So remember, I want the second tile to be greater than the first. So that's no good. This one is. This one is as well. This one is no good. This one is no good. That one's okay, and none of these 3 involve taking a second tile greater than the first, because the first one I took was the biggest tile in there. So there are 3 possible things that can happen out of 9. So what I'm going to do is I'm going to look at the probabilities of each one of these individually. The probability of a 1 and a 2 is 6 out of 42. The probability of a 1 and then a 3 is 4 out of 42, and the probability of a 2 and then a 3 is 6 out of 42. So what I'm saying here is I want the probability of this event happening, or this event happening, or this one. And in probability, when I say the word or, that means that I add the probabilities together, which will give me a total probability of 16 out of 42, which I would simplify down to 8 out of 21 for my final answer.